Hello, Eric here with SkySwitch. The other day we posted a video to our YouTube channel explaining how our Geo-Redundant network worked. That video was pretty detailed, and if you haven't seen it yet, I recommend you taking a look at it if you're interested in learning more about SkySwitch's architecture. But it led to a question from a reseller that said, well, my other provider also has a redundant network, but they don't have the same kind of uptime. What makes your network different than theirs? So I thought I'd put together this short video to explain the difference. It really boils down to active-active versus active-spare technology. So first, just a little reminder about how the SkySwitch network works. We have 3 geo-redundant nodes operating in New Jersey, Dallas, and Las Vegas. And those 3 nodes are available to any reseller at any time. Now, what happens in practice is when a phone first boots up, it contacts the SkySwitch provisioning server, and the provisioning server gives the phone 2 DNS records. DNS-A is the primary server, and DNS-B is for the failover server. So with that information, the phone knows that it can contact the primary server and use that. But if there's ever any problem with the internet or a co-location problem, or maybe a server in the co-location facility becomes unavailable, well then the phone knows that it can contact the secondary server. This is good because it puts the failover intelligence at the most granular level, which is in the phone itself. And it's possible because our servers use end-share technology, which is also known as active-active technology. And what that means is that all information on any server is available to all the other servers in the network in real time, so that any phone can connect to any server and get the same kind of service. The alternative to active-active is active-spare. And that's what some providers use and refer to as their redundant network, but it's really quite different. Because with active spare, what happens is that when the active server is no longer available, the system has to switch over, and it says, okay, well now the spare becomes the main server. In that case, the active server is out of the picture and the spare is available. Now, that switch over is usually not seamless. It takes some time and usually a lot of orchestration behind the scenes to make sure that that failover takes place. The problem is, though, when you have a lot of servers, say dozens or even hundreds, well, it's hard to program the phones to know where's the active server and where's the failover server. And when a failure occurs, getting the system to figure out where to send that failover call is sometimes tricky. One of the ways some providers do it is to put a load balancer in front of their network. And so when the phone first registers, it registers to the IP address of their load balancer. The load balancer is programmed to know where the active server is. And if there was ever a problem with the active server, then in theory, the load balancer knows where the failover server works. The problem is, though, with hundreds of servers, it's often tricky to get this all right. What many providers have learned the hard way is that the load balancer introduces a single point of failure that can take a whole network down. And getting that fixed can often take hours and sometimes even days. So there you have it. The difference between SkySwitch and many other providers who claim to have redundant networks is active-active versus active-spare. So next time you talk to another provider who claims to be redundant, you'll know what questions to ask. Hope this was helpful. Thanks for watching.